In this class, we are going to be talking about alkanes. So, what are alkanes? Alkanes are hydrocarbons, basically. And what are hydrocarbons? They are an homologous series under the hydrocarbons. Now, hydrocarbons are organic compounds which are formed from just carbon and hydrogen. And so they are just homologous series, and homologous series are families of compounds that they differ by CH2. Now we're going to be talking about alkanes very briefly. So I want you to first put this in mind that they differ by CH2. Now, alkanes are the first set of hydrocarbons which are very saturated. The first thing is that they're saturated. The second thing which we are going to look at under its properties is the fact that because they are saturated, they are non-reactive. They are non-reactive. It's now very slightly reactive, not reactive to slightly reactive, any one of the two. So which means that they do not accept any other element, since they are very saturated. So we are going to talk about how they look. But the first things first, we want to look at their general formula. Now, what is the general formula of alkane? General formula of alkane is CnH2n plus 2. So commit this to mind. This is CnH2n plus 2, which is the general formula for the alkanes. Now, from this here, we can talk about the first 10 compounds of the homologous series alkane. So now let's say when your n is equal to 1, you put 1 into this place here, substitute 1 here, you'll be having C1H2 into bracket 1 plus 2. So from here, this gives me CH4. Now we call this one here, call it methane. Now, this is another thing you should take note of, is that alkanes have the suffix "ane." And they have the suffix "ane." So that means for everyone we are going to be talking about in this class here, under the alkanes, they have anes. You understand? Every one of them have anes. So for the second one, the second compound, from here we are going to be having C2H6. This is going to give me ethane. If you do the same arithmetic here, you'd have C2, H2 times 2, which is 4, plus 2, which is 6. So that gives me C2H6. Now you move to n equals to 3. That gives me C3H8, which is propane. And of course, this is not going to contain it. I'll just switch to the next screen. We have n equals 4, which is ethane. Sorry, rather it's butane. Apologies. This is butane, which is C4H10, which is butane. We have C5H, which is pentane. We have C6H14, which is hexane. Now from this place, I'm only going to write the name. You guys should try the remaining by yourself. That will be your first class work. We have heptane. We have octane. We have nonane. And then we have decane. So these are the first 10 compounds of the homologous series. So they are the first 10 of the series. So from this place here, can now talk about their properties. What are the properties of these guys here? Now the properties exist as this. The first one here, we have their state of matter. Let's talk about the physical properties. So we know that from the C1 to C4, which is basically from methane, methane to butane, we know that it is gaseous. And then it changes from C5, which is liquid, to C12. And then from C12 upwards, becomes solid. Now, we'll not talk about, this is just the physical property. We have the boiling point. It increases as you go up. We have the, what they call the viscosity, also increases. Viscosity is the resistance to flow. So that means it goes up, because from gaseous to liquid to solid, you can see that the intermolecular attractions or interatomic attractions get higher. So now, what are the chemical properties? Let's talk about the chemical properties. of, we have your alkanes. Alkanes. Now, what are the chemical properties of alkanes? The first one is it is not reactive. Let me just put non-reactive or less reactive. Let's just put less reactive in this case here. Now, it doesn't react in what case? It means that it does not undergo addition reaction. And why is this so? It's because it is saturated. There's no need for extra atoms inside it at all. So from this place here, because of there is no addition reaction, whenever there is a reaction between other elements, you see that there are no changes at all. Example, bromine water, which is used to test alkanes. You see that it does not react when you react them with alkanes. Now, the second one is that even though they don't undergo addition reaction, they undergo what we call substitution reaction, which in this case here, substitution reaction, say for example, I have carbon here, hydrogen. Let's use methane as an example. This here is methane. And then I react it with chlorine. Now from this place I would see that one of them is swapped and then it takes on one chlorine in this place. Now when there is a swapping of hydrogen to replace with chlorine or any other compounds, you understand, maybe like an halogen, maybe like oxygen, maybe like hydroxyl and so on and so forth here, we would see that there is substitution reaction. It's just like when you are playing football on the field and you take one person out and you bring another person in, and so you are replacing one hydrogen atom with a chlorine atom. So from this place here, this here will now give me, because this is CH4, from here I'll be having CH3Cl, which in this case here becomes CH3, and then one of it becomes Cl. Now the hydrogen that has been swapped from this place here now acts with the remaining chlorine, and then we have hydrogen chloride. Hydrogen chloride. So this here becomes a chloroform, which is known as chloromethane. And then this is hydrogen chloride. So from here, it's saying the substitution reaction. Now the last reaction is the oxidation reaction, which I would like to call combustion reaction myself, by the way. Combustion reaction. So for combustion reaction, what do we have here? We'll see, say for example, we take methane, once again, use methane as an example, plus oxygen, because combustion is the burning of a substance in the presence of oxygen. From this place here, what we are going to be having is two products, which the first one here gives us carbon 4 oxide plus H2O. So we've seen that alkanes can undergo substitution from just using methane in this place here. Every one of them undergo substitution. It's the same thing too. Alkanes can undergo combustion. So alkanes plus oxygen gas gives you carbon 4 oxide plus what? Plus water. So in this case here, this is another reaction that they undergo. Like this should not be too hard for you to understand. If you have any questions, drop them in the comments down there. Now, from this place here, we've now seen the three types of reactions that it undergoes. Now from here, we should be able to enter into nomenclature. Now let's just see some namings and then we'll wrap it up. Now, this is going to get very, very tricky, so I would like you guys to stay with me. Now, the first step towards doing this is you check which is the longest chain. That's the first thing. The first thing is the longest chain. You check for the longest carbon chain. So, what do I mean by chain? Is how long the carbon to carbon bonds are. Now, one thing I would like to chip in is that alkanes have a single bond. As you can see, they have a single bond and that becomes their functional group. Alkane's functional group is the single bond. It's a single bond. So because of the single bond here, You understand? That's why they are saturated. So this goes to show us that the functional group is the defining function of an homologous series. What do I mean? It means that so for an homologous series behaving a particular kind of way, you understand, the reactions they undergo are determinants of their, what do you call it, of their functional group. So the fact that an alkane cannot react means that it is saturated, and the sign of saturation is a single bond. Now the single bond is known as your sigma bond, which is also written this way, sigma bond. So with that, yes, you look for the first thing is the longest chain. So from here we can clearly see that if you have counted this, carbon to carbon to carbon to carbon to carbon to carbon, we have 6 of them. You count 1, 2, 3, 4, 5, 6. Now we've seen if you count this way, 1, 2, 3, 4, 5, 6. Same thing, count this way too, gives you the same thing. We count like this, you look at this carbon here, you see to both sides is shorter than this one. What we are looking for is the longest chain. So from here, the longest chain is 6. So that's how you name. So we know that the compound here, since we have one bond, understand, if I draw this, it's going to be very, very chaotic. But it should look somewhat like this. Let me try. We have carbon to carbon. Yeah, in this place here, carbon. So this is 6 of it. On the third one here, I have CH3, and here I have CH3 and then CH3. Now look, we have not we've not exceeded the limit for every one of their bonds in this place here, because we know that carbons form 4 bonds. Understand? Carbons form 4 bonds because they are tetravalent. And tetravalent means that they have 4 electrons on the octet shell, which means they have to balance it by gaining 4 more electrons, thereby forming 4 bonds. So from this place here, we can see that carbon here, we have 6 of it. Since it is a single bond, we have what? Hexane. That's the first thing you write. Now we are not done. We have these additions here, which we call the appendages, by the way. So from here, we have 1, 2, 3 in this place here, and all of them are CH3. Now this is another thing I would like to teach you about. We have the compound called the alkyls. Now I'm going to switch my screen for a bit, so you guys should follow me. So we have the alkyl compounds. So the alkyl compounds are alkane compounds that have lost an hydrogen. So they've lost an hydrogen, therefore they become alkyl compounds. They transform and become alkyl compounds in this case here. So after they've lost one hydrogen, alkanes minus hydrogen, one hydrogen becomes an alkyl. So say for example, I have CH4, which is methane, minus one hydrogen gives me CH3. Now this one here becomes methyl instead of methane. So we see C2H6 minus one hydrogen here becomes C2H5. You can play with it, check, pause the video, try the other ones, and then learn how to name them. It will give you ease and access to all these things. Now from here we have in this place here I have 3 of it. Now another thing, the second rule from this place is you would count. You understand? You take the one with the what do you call it, the smallest number. So take the smallest number, take the carbon with the smallest number, the carbon that has appendage with the smallest number. So again, you take the carbon that has an appendage with the smallest number. Okay, so now let's count from the front. 1, 2, 3, 4, 5, 6. All these things we are doing them to name them. Let me use a different color instead. Let me use a different color. So stands out 2, 3, 4, 5, then 6. So if I count from the back, counting both ways, I have 1, 2, 3, 4, 5, 6. Now you see the carbon that carries the appendage here. For this one here, when you're counting forward, it is 3. So I'm just going to say this is the smallest number here. This is 3. Now if I count backwards, this is the carbon carrying the appendage. Inside this place here, the appendages. This one here, it is in the counting from the back. We have 2. Now you see 2 is less than 3 in this place here. So we will go with the backward naming. You understand? We'll go with the backward naming. So you choose the carbon that has the smallest number, and you use it to name your compound. You understand? The carbon carrying the appendage that has the smallest number, use it to name your compound. I've mentioned that 5 times now. So from here we have 1, 2. On the second carbon, I have 2 of it. And then on the fourth carbon, counting from the back, I have 2 of it also. Let me wipe the top one so it doesn't confuse people. Yes, so back to this. So from here, I have 1, 2, 3, 4, and then 5, and then 6. So on this place here, I have 2 of this, and then 3 of it. Now, so this gives me trimethyl. If you look at this from the alkyl compound, this is methyl. So I have 3, 2 is di, 3 is tri, 4 is tetra, 5 penta, 6 hexa. So from this place here, we have 1, 2, and then 3. So this here is tri. So I count. On this one here, I have it 2 of them on 2. So this I'm going to write 2 of it. So I write 2, 2. Another thing is, note, between numbers and numbers, you put comma. Between numbers and letters, you put hyphen. So from here, in this the third one here is on 4. Now the reason why I'm writing all 3 numbers together is because they are similar. And they are similar. If they were not similar, I will not put them in the same place. So this here is 2,2,4 trimethylhexane. So again, don't forget to put your word recording. So now if I write this, let me write it. So this is giving me 2,2,4 trimethylhexane. And make sure you write them as a single word. So we've named it like this. If you do not understand, pause the video, go back again, we watch them. So my own question for you guys to try out will be this. Let's try this one out. So question number 2, you can try it out by yourself. CH3, CH2. So from here, try this one out. Let me know your answers in the comment section. So in the next video, we'll be talking about the alkanes. Thank you very much.